to start the next exercise, which is exercise number 1.5. Here the question number first is find second order derivative and the function 2x raised to the power 5 minus 4x cube minus 2 upon x square minus 9. Here we have to find second order derivative. It means that if the given function y is equals to f of x, after differentiating with respect to x, we get dy upon dx, which is f dash of x. It's a first order derivative. But here we have to find second order derivative. Hence, if we have again differentiate with respect to x, then we get a second order derivative which is dy by dx is equals to derivative of f dash of x. Derivative of which is dy upon dx with respect to is d2y upon dx square is equals to f double dash of x is called as second order derivative. So the given function is 2x to the power 5 minus 4x cube minus 2 upon x square or minus 9. If the given function is in the form of y is equals to f of x, we can calculate second order derivative. Now first, let us consider that the whole function which is y is equals to, let y is equals to 2x to the power 5 minus 4x cube minus 2x square minus 9. If we differentiate with respect to x, the derivative of y which is dy by dx, so we can take a separated derivative of every terms. 2 is constant, we can take a derivative of x raised to the power 5 minus 4 into derivative of 4 is constant x cube minus 2 into derivative of 1 upon x square, we can write it x raised to the power minus 2 and minus the derivative of 9. So the derivative of x raised to the power 5 is 4x raised to the 5x raised to the power 4 minus 4 into derivative of x is 3x square minus 2 into derivative of x raised to the power minus 2, which is minus 2 x raised to the power minus 2 minus 1 minus 3, and the derivative of 9 which is constant function is 0. If 2 into 5 which is 10 into x raised to the power 4 minus 4 into 3 12x square minus plus 4x raised to the power minus 3, which is the derivative of y with respect to x dy by dx. But we have to find second order derivative. Dy by dx is an first order derivative. If we differentiate first order derivative again with respect to x, then we get second order derivative. So again differentiate with respect to x, the derivative of dy by dx which is d2y upon dx square, we can take cos 10 is constant, we can take a derivative with respect to x to the power 4 minus 12 constant derivative, we can take x square plus 4 into derivative of x raised to the power minus 3, which is 10 into derivative of x raised to the power 4x cube minus 12 into x square derivative 2x plus 4 into minus 3x raised to the power minus 3 minus 1 x raised to the power minus 4. Therefore 10 into 4 which is 40x cube minus 12 into 24x plus minus 12x raised to the power minus 4, or we can write 12 upon x raised to the power 4, which is a second order derivative, or require d2y upon dx square second order derivative of the given function 2x raised to the power 5 minus 4x cube minus 2 upon x square minus 9. So the next example is again e raised to the power 2x into 10x. Here again we have to find second order derivative which is d2y upon dx square. Similarly, first we consider whole function y is equals to e raised to the power 2x into 10x. E raised to the power 2x and 10x be a two differentiable function, which is if we apply here u into v rules, and we know that the derivative of u into v which is u into dv upon dx plus v into du upon dx. So here if we differentiate with respect to x, we can take y with respect to dy by dx e to the power 2x into derivative of second function tan x, again first second function into derivative of first function e to the power 2x. Here e to the power 2x as it is, and the derivative of tan x which is sec square x plus tan x as it is and the derivative of e to the power 2x is e to the power 2x, and the derivative of again d2x, which is the 2, or derivative of 2x. So here if we take e to the power 2x common both, we can write e to the power 2x into sec square x plus 2 derivative of 2x, which is 2 tan x. So which is dy upon dx means first order derivative. But we have to find here second order derivative means d2y upon dx square. So if we differentiate again with respect to x, the derivative of dy by dx, which is d2y upon dx square, we know that it is second order derivative or higher order derivative. Here, if we apply here u into v rules, we can write e to the power 2x into derivative of sec square x plus 2 tan x plus, again we can write sec square x plus 2 tan x into derivative of e to the power 2x. Now here e to the power 2x again as it is derivative of sec square x, which is 2 sec x by using the rules of x to the power n, and again derivative of sec x we can write sec, or we can write derivative of sec x plus 2 constant derivative of tan x, which is sec square x plus sec square x plus 2 tan x as it is, and the derivative of e to the power 2x, which is 2 e to the power 2x. Here again we can take e to the power 2x common from both terms. We can write e to the power 2x into 2 sec x, and derivative of sec x, which is sec x into tan x, means 2 sec square x into tan x plus 2 sec square x plus sec square x into 2 sec square x plus 2 into 2 4 tan x. So if we take sec square x common from this both, we can write d2y upon dx square is equals to e to the power 2x, e to the power 2x. Here if we take sec square x common from these three terms, we can write sec square x into 2 tan x plus 2 we can write it, if we take sec square x common from this term, 2 sec square x plus 2 sec square x is 4, we can write e to the power 2x into 2 sec square x plus into tan x plus 4 sec square x plus 4 tan x, which is a required derivative or second order derivative of the given function, which is d2y upon dx square. So again we have to find here second order derivative and the given function, which is e to the power 4x into cos 4x. First we consider that y is equals to e to the power 4x into cos 5x. Here we have to find second order derivative, means d2y upon dx square. First we differentiate with respect to x the derivative of y, which is dy upon dx. Here by using the rules of u into v, we can write e to the power 4x into derivative of cos 5x. Again plus cos 5x, and we take again the derivative of e to the power 4x. Now e to the power 4x as it is, and the derivative of cos 5x, which is minus sin 5x, and we take again the derivative of 5x plus cos 5x as it is. Derivative of 4x is 4 into e to the power 4x, or e to the power 4x, and we take again the derivative of 4x. We can write it e to the power 4x minus sin, or we can write it, if we take e to the power 4x common from both term, we can write e to the power 4x into derivative of 5, which is 5, minus 5 sin 5x, derivative of 4x, which is 4, e to the power 4x taking common, 4 plus 4 cos of 5x. Now we have to find here second order derivative is d2y upon dx square. So if we differentiate again with respect to x, we can write it d2y upon dx square is equals to e to the power 4x, and we take again a derivative of minus sin 5x plus 4 cos of 5x plus minus 4 sin 5x plus 4 cos of 5x into derivative of e to the power 4x. So we know that if we take e to the power 4x is equals to e to the power 4x, derivative of minus 5 constant sin 5x is cos of 5x, and the derivative of 5x again, which is 5 plus 4 into, or we can write derivative of 5x by using chain rule, plus 4 into derivative of cos of 5x, which is minus sin 5x, and we take again a derivative of 5x. Here minus or plus minus 4 sin 5x plus 4 cos of 5x as it is, and the derivative of e to the power 4x, which is 4 into e to the power 4x. If we take e to the power 4x from both common terms, we can write it e to the power 4x into e to the power 4x into 5, derivative of 5 is 5 minus 25 cos of 5x plus derivative of 5x, which is 5 into 4 20 plus minus 20 sin 5x plus minus 4 into 4 minus 16 sin 5x plus 4 into 4, which is 16 cos of 5x. So minus 25 cos 5x and plus 16 cos 5x minus 20 sin 5x minus 16 sin 5x, we can write d2y upon dx square is equals to e to the power 4x into minus 20 minus 16 minus 36 sin 5x minus 25 plus 16 minus 9 cos of 5x. If we take minus sign common from both terms, or minus 9 common, we can write e to the power 4x 4 sin 5x plus cos of 5x, which is a required second order derivative d2y upon dx square. So the next one, which is x cube log x. If we consider that y is equals to x cube log x and differentiate with respect to x, we get derivative of y, which is dy by dx. By using the rules, which is u into v, we can write product rule x cube into derivative of log x plus log x into derivative of x cube. Here derivative of log x, which is 1 by x, plus log x into derivative of x cube is 3x square. X cancel, we get x square. X square is equals to x square plus 3x square log x. So here we can write, if we take x square common from both terms, we can write 1 plus 3 log x, which is the dy by dx. But we have to find here second order derivative, means d2y upon dx square. So if we again differentiate this function with respect to x, we can write derivative of dy by dx, which is d2y upon dx square. X square into derivative of 1 plus 3 log x plus again 1 plus 3 log x into derivative of x square. So x square into derivative of 1 0 plus 3 into log x, derivative of 1 log x, which is 1 by x. Now again we can write 1 plus 3 log x as it is, and a derivative of x square, which is 2x. Here x square into 3 by x plus 2x into 1 plus 3 log x. So required derivative, which is here, if we cancel get x square, we can write 3x plus 2x into 1 plus 3 log x. So if we take 3 common from both terms, we can write d2y upon dx square is equals to x into 3 plus 2 into 1 which is 2 plus 6 log x. 2 plus 3 which is 5, x into 5 plus 6 log x which is a required second order derivative d2y upon dx square. So the next example, which is log of log x. If we consider that given function which is y is equals to log of log x, and if we differentiate with respect to x, then the derivative of y which is dy by dx, and we take a derivative of log x. Derivative of log, if we consider this log x which is x, and the derivative of log x is 1 by x, we can write the derivative of log x which is 1 upon log of x. And if we take again a derivative of log x by using a chain rule, so the derivative of log x which is again log x, we can write 1 upon log of x into derivative of log x is 1 by x. Hence we can write dy upon dx is equals to 1 upon x into log x. Here we have to find second order derivative, and a function which is dy by dx is equals to 1 upon log x is a first order derivative. So again differentiate with respect to x. We can write this x which is in numerator x raised to the power minus 1, which is minus x raised to the power minus 1 upon log of x dy upon dx. If we differentiate with respect to x by using u upon v rules, we can write d2y upon dx square is equals to log x into derivative of x raised to the power minus 1 minus x raised to the power minus 1 or 1 by x into derivative of log x upon log of x whole bracket square. Now we know that derivative of x raised to the power minus 1 which is minus 1 upon x square minus 1 by x as the derivative of 1 by x which is 1 by x upon log of x whole bracket square. So minus 1 upon x square into log x minus 1 into 1 which is 1 upon x square upon log of x whole bracket square. If we take 1 upon x square common from both terms, we can write minus 1 upon x square into 1 plus log x or log of x plus 1 upon log of x whole bracket square. If we write this denominator minus 1 plus log x upon x log x square into log of x whole bracket square, or d2y upon dx square is equals to minus 1 plus log x upon x log x whole bracket square, which is a required second order derivative of the given function, which is function is log of log x. Here again we have to find second order derivative, which is function is x raised to the power x. So if we take direct derivative of the function x raised to the power x, then there is not a derivative available in the form of function f of x raised to the power g of x. Hence first we take log both side, then y which is log y is equals to log of x raised to the power x. So we can write it log of y is equals to x log of x. If we differentiate with respect to x, then we can write the derivative of log y which is 1 by y dy upon dx. Here x into derivative of log x plus log x into derivative of x. Here if we take this y right side, we can write y into x into derivative of log x 1 by x plus log x into derivative of x which is 1. The value of y which is x raised to the power x into x cancel 1 plus log x which is dy upon dx. But we have to find second order derivative, means d2y upon dx square. So if we again differentiate with respect to x, we can write derivative by using u into v. d2y upon dx square is equals to x raised to the power x into derivative of 1 plus log x plus again 1 plus log x into derivative of x raised to the power x. Here x raised to the power x as it is, derivative upon 0 log x derivative 1 by x. Again 1 plus log x as it is. Here x raised to the power x means y, and the derivative of y, which is dy by dx, means derivative of x raised to the power x, which is x raised to the power x 1 plus log x. We can write x raised to the power x into 1 plus log x. So we can write it from equation 1. Here x into x raised to the power x raised to the power x upon x plus 1 plus log x into 1 plus log x, which is x raised to the power x into 1 plus log of x whole bracket square. If we take x raised to the power x common from both terms, or we can write x raised to the power x into, here the power of x is 1. If we take in numerator, we can write x raised to the power minus 1 plus x raised to the power x into 1 plus log of x whole bracket square, which we can write it x raised to the power x minus 1 plus x raised to the power x into 1 plus log x whole bracket square, which is the d2y upon dx square, second order derivative or higher order derivative of the given function x raised to the power x. Next question in the exercise number 1.5, which is question number 2, and the question number 2, find d2y by dx square. Here function x is equals to a cos theta and y is equals to 1 minus a into 1 minus cos theta. Again, these both function x and y are in the parametric function with a parameter theta. If we have to find the derivative, which is dy upon dx, then we use here derivative definition of derivative, which is parametric functions. Dy by dx is equals to dy by d theta upon dx by d theta. Hence, first we have to find dx upon d theta and dy by d theta. After using the definition of parametric function, we can find dy by dx. Again differentiating, we can find second order derivative, which is d2y upon dx square. So first we differentiate x and y both with respect to theta. Derivative of x, which is dx by theta, here a is constant and we take a derivative of which is cos theta. Here again we can write y is equals to a into derivative of 1 minus cos theta. Here a into derivative of 1 0 derivative of minus cos theta, which is a minus sin theta. Here minus minus plus a into sin theta. Here dx upon d theta, which is a into derivative of cos theta, which is minus sin theta. Here we can write minus a sin theta. Here function which is x is equals to a into cos theta, not a into theta minus cos theta given. Minus sin theta, theta minus sin theta is given. Hence we can write derivative of theta minus sin theta, derivative of theta which is 1 and derivative of sin theta which is cos theta. Here a in bracket 1 minus cos theta which is 1 and a sin theta which is 2. So by using the definition of parametric function, we can write dy upon dx is equals to dy by d theta, which is a sin theta, and dx by theta, which is a in bracket 1 minus cos of theta. Here a cancel. We can write sin theta, which is 2 sin of theta by 2, and cos into cos of theta by 2 upon 1 minus cos theta, which is 2 sin square theta by 2. Here 2 cancel, sin of theta by 2 square cancel. We can write cos of theta by 2 upon sin of theta by 2, which is cot of theta by 2 with dy by dx. But we have to find derivative which is second order d2y upon dx square. If we differentiate with respect to x, which is dy by dx, we get a d2y upon dx square is equals to derivative of cot theta by 2. Here parameter is theta, differentiable function is x. If we can write d upon d theta into cot of theta by 2, then we can take a derivative of cot of theta by 2. If we adjust here d theta, we can write adjustment d theta in numerator and dx as it is dx by d theta. Derivative of cot theta, which is minus cosec square theta by 2 into again a derivative of theta by 2. So we can write d theta upon dx, which is 1 upon dx by theta. We know that the value of dx by d theta, which is y in bracket 1 minus cos theta. Hence, derivative of theta by 2, which is 1 by 2 into minus 1 minus cosec square theta by 2 upon 2 into 1 upon dx upon theta, which is a in bracket 1 minus cos theta. A in bracket 1 minus cos theta. Here, minus cosec square theta by 2 upon twice a 1 minus cos theta, which is a required derivative d2y upon dx square of the given functions. So again here we have to find d2y by dx square. If we differentiate x and y with respect to parameter t, then we can write the derivative of dx by dt and dy by dt. So here derivative which is dx upon dt is equals to twice a constant. We can take a derivative which is t square. Derivative of t square is 2t. We can write 2 into 2 4at 1, which is dx by dt. Again y is equals to 4at. Derivative with respect to dy by dt, 4a constant, we can take a derivative of t. 4 into derivative of t 1, which is we can write 4a number 2. So by using the definition of parametric function, we can write dy upon dx is equals to dy by dt upon dx by dt. dy by dt is 4a and dx by dt is 4at. Here 4a cancel, remaining 1 by t, which is a dy upon dt. But we have to find second order derivative, which is d2y upon dx square. So if we differentiate with respect to x, we can write derivative of dy by dx is equals to derivative with respect to x dy by dx, which is d2y upon dx square is equals to derivative with respect to x 1 by t. T is differentiable function but not x. If we consider that t, which is x, we can write derivative of 1 by t with respect to x is minus 1 upon t square, and again a derivative of considerable function, which is d derivative d upon dx of t. So minus 1 upon t square into dt by dx. We can write this dt by dx is 1 upon dx by dt, and the value of 1 upon dx upon dt, dy by dt, dx upon dt is 4at. Means we can write 1 upon 4at minus 1 into 1, which is minus 1 upon 4at square into t cube, which is a required derivative or higher order derivative d2y upon dx square. Here we have to find definite value at theta is equals to pi by 2, which is higher order derivative or second order derivative d2y upon dx square. Given function is in the parametric form. Here first we differentiate both with respect to theta in both x and y. Here theta is parameter. If we can take a derivative with respect to theta, we can write dx upon d theta into derivative of sin theta, and the derivative of sin theta, which is cos theta 1. Again we can write dy upon d theta. We take a derivative which is sin theta whole bracket cube. We can write 3 sin square theta into again derivative of sin theta, which is cos theta, here number 2. By the definition of parametric function, TF means parametric function, we can write second order derivative, dy upon dx is equals to dy by d theta upon dx upon d theta. Here dy by theta is 3 sin square theta into cos theta upon dx by theta means cos theta. Here cos theta cancel, we can write 3 sin square theta, which is dy upon dx. But we have to find second order derivative. If we again differentiate with respect to theta, we can write d2y upon dx square is equals to 3 is constant. We can take a derivative which is sin theta whole bracket square. By using the derivative which is x raised to the power n, we can write d2y upon dx square is equals to 3 into derivative of sin square theta, which is 2 sin theta, and we take again the derivative of sin theta. We know that here 3 into 2, which is 6 into derivative of 2 sin theta, sin theta is the derivative of sin theta, which is cos theta, or we can write 3 into 2 sin theta into cos theta. Here we know that 2 sin theta into cos theta, which is cos 2 theta d2y upon dx square. But we have to find the value of d2y upon dx square at theta is equals to pi by 2. We know that 3 into cos of 2 into pi by 2, 2 to cancel, 3 into cos of pi into cos pi. The value of cos pi, which is 1, 3 into 1, 3, which is the required derivative or second order derivative, d2y upon dx square is equals to 3. Here we have to find d2y upon dx square, theta is equals to pi by 4. So if we differentiate with respect to theta, we can write derivative of dx upon d theta is equals to a is constant function, derivative of cos theta. Derivative of cos theta, which is minus sin theta, we can write minus a sin theta, which is 1. So again, dy upon d theta, which is b into derivative of sin theta, and the derivative of sin theta, which is cos theta number 2. By the definition of parametric function, we can write dy upon dx is equals to dy by d theta upon dx by d theta. The value of dy by d theta, which is b cos theta, and dx by theta, which is minus a sin theta. We can write cos upon sin part, we can write minus d upon a cot theta, which is the dy by dx. But we have to find second order derivative, hence we again differentiate with respect to x. We can write second order derivative d2y upon dx square minus d upon a, which is constant function, and we take again a derivative of cot theta with respect to x. So here derivative of cot theta minus d upon a into derivative of cot theta, which is minus cosec square theta into dx upon dt, d theta upon dx. Considerable function which is theta, and with respect to d theta upon dx. We can write minus d upon a minus plus cosec square theta. We can write d theta upon dx, which is dx upon d theta. Here the value of dx upon d theta is minus a sin theta. We can write is equals to b upon a cosec square theta into 1 upon the value of dx upon d theta is minus a sin theta. Cosec square theta means 1 upon cos square theta, or this minus a b upon a square cosec square theta into 1 upon sin theta means again cosec theta. which is minus b upon a square into cosec cube theta or cosec theta bracket cube. But we have to find second order derivative at theta is equals to pi by 4. Hence d2y upon dx square at theta is equals to pi by 4. We can write minus b upon a square into cosec of pi by 4 bracket cube. Cosec, the value of cosec of pi by 4, which is under root 2 bracket cube. Hence we can write minus 2 root 2 b upon a square, which is a required higher order derivative at theta is equals to pi by 4.